Okay, we're recording.
Well, howdy, we're Team Spark, and we are presenting our finalized proposal for the city of Nolanville. Team Spark focuses on promoting sustainable growth through integrated infrastructure approach. This semester, the goal of Team Spark is to enhance the sense of community and improve mobility in Nolanville. We created plans for a smart district in Nolanville to serve as a gathering place for residents and commercial center while incorporating ecological elements, access to transit, and community kiosks to enhance connectivity. Additionally, we planned several routes for last mile transit within Nolanville to serve older and disabled residents and those without access to reliable transportation. These routes will serve public and commercial points of interest within Nolanville and tie into current and proposed routes for the hub.
Our team is comprised of the aggregation of various disciplines, which all contribute various skill sets and methods of problem solving to our project. These disciplines include civil engineering, visualization, landscape architecture, urban planning, computer science, and USAR.
To approach this project, our team began problem seeking by examining the what, where, why, who issues that Nolanville is currently facing, such as the food desert, weak connectivity, and lack of open space. To mitigate these issues, our team sought to problem frame these issues by focusing on economic, environment, and connectivity that we deem will enhance the well-being in the community. To execute this idea, our team is broken up into 4 sub-teams for proposing different smart interventions, which include the smart district, agriculture, route planning, smart kiosk, and population growth. Each intervention addresses the different focus areas, which are all interconnected with each other. We deemed it essential to propose our interventions in the downtown area in order to enhance and further its potential. As you can see in this map, the agriculture is located on the far left, the smart district is in the middle, and the night market on the right. The existing commercial is within the downtown area adjacent to the night market in the near smart district, while the residential portion is mostly surrounding all the proposed sites on the north and east. Now we will begin discussing the smart district. This is the proposed intervention in context to Nolanville with the smart district on the west side of downtown and the night market on the east. The general design of the smart district is a corridor with an alley of trees and smart lighting slicing through the smart district for accommodating the autonomous vehicles. The smart district was designed to be pedestrian friendly with an urban carpet north of the alley, which has a series of programming. The primary spaces in this area is the Shade Structure Plaza, Splash Pad, Tree Plaza, and Cinema Lawn. This diagram shows the commercial use and circulation in relation to its surrounding context. The light pink is the movie theater, the light purple is restaurants, and the light green is small businesses and retail. The smart elements include autonomous vehicles, smart lighting, smart kiosks, and kinetic paving. This diagram shows their locations within the smart district. The smart lighting will use sensors to make adjustments based on conditions such as occupancy or daylight availability. The kinetic paving draws usable energy from footsteps. This generated energy will be used for the smart lighting. The smart kiosk and autonomous vehicles will be discussed further in the presentation. This LA will serve as the route for the autonomous vehicles for enhancing the connectivity to create a sense of boundary and defined space. The smart lighting and street trees follow along the route within the smart district. The Water Plaza features splash allows for a series of programming in the plaza, such as an outdoor theater, concert, local markets, outdoor cafes, and more. The cinema lawn can serve as a multi-use lawn for various recreational activities, such as an outdoor movie theater, as you can see here in this rendering.
When we first analyzed Nolanville's problems, one of the most prevalent was the lack of a community food source, so we began to consider an agricultural alternative. The idea soon morphed from having a simple agricultural yard to providing an intervention that increased access to nature and its benefits in Nolanville. The agricultural portion of the design includes not only space for gardening, but also increases space for community gathering and active recreation, as well as restoring a floodway and enhancing the street design to increase safety. Increasing the safety of the city would begin by adding a roundabout to a lower speed in the growing community, adding tree-lined sidewalks and dedicated pedestrian crossings would ensure the residents remain protected from vehicles. Likewise, having Nolanville buy property that commonly floods would allow the city to control the flooding by creating a detention basin, therefore protecting residents from increasing storm events. In this floodable plot, the city would be able to introduce community farming plots, a miniature orchard, and a formal gardening center. In this view, you see the proposed formal gardening center, where a vast array of common vegetables could be cycled through yearly, providing community members with fresh produce supplemented by a miniature orchard. Adjacent to the formal gardening center is a proposed community pavilion. Members of the community could gather here to celebrate local events or even host workshops and field trips. Paths crossing through wild forbs and grasses would connect trail systems leading to a resting area in front of the flood basin, as well as an active maintained yard space where families could play games or children entertain themselves while family members experiment with gardening methods in the large pot across the yard.
Next, we'll be discussing our smart kiosk. This kiosk was in collaboration with Mario from Endeavor One. He designed the desktop version. Applications within the kiosk include events held within the city, carpool or rideshare, easy forms to fill out for common problems like maybe a pothole or a noisy neighbor, job opportunities, notifications or announcements from local city officials, civic resources, and surveys, similar to what was done with the potential HEB. Our kiosk is a community kiosk for better connectivity inside the city, solutions for upcoming events, resources for city issues, and smarter transportation schedules. Here's a better look at where our kiosks will be located within the Smart District. Following are the UI UX components of the kiosk, like color, typography, and iconography. Here's the low fidelity mockup, and then our mid fidelity mockup, and our high fidelity working prototype.
Now, computer science has been working on developing different population projection models that could be used by Nolanville. The output from these models can be used by city leaders to make informed decisions when considering economic development opportunities and to estimate things such as future tax revenue, to fund such projects, especially those in our presentation. The data we used came from the Texas Demographic Center, and it includes information on age, sex, and race for all 254 Texas counties from the years 2011 through 2018. Now, one way we use the data was to split up the population into age ranges. Then we filtered it to only include those counties with similar size to Nolanville's county. Then a linear regression model was then trained using the age ranges as features to predict 1 to 5 years into the future. However, our predictions are limited by the small amount of data that is available to us at the moment. Now, when training the model for a 5-year projection, we get the linear regression model shown on the right. Overall, we can see an increase of population for Bell County. The correlation is actually pretty high, and the average error is not too bad, which is good. But again, the data available has limited the capabilities of our models.
For the population demographic model, the features that we used were Hispanic, Anglo-American, African-American, and other. We try to use concrete numbers and demographic percentages to see which would be more accurate for the output. The picture on the bottom left shows how each feature correlates with one another. The closer to 1, the better. The features that correlate best with the output are the actual numbers, not the percentages, so we toss the percentages out. We also tried looking at various different models and concluded that linear regression was the most accurate. The bottom right picture shows one of the models we tried, which was a decision tree. The problem with that model was that the output that we were getting didn't match a lot of the other models, and it had a lower R value than the other ones. Since our data is from 2011 to 2018, we trained our model for 2011 and through 2017, and then we tested it on 2018. And for the 2018 model, since we trained it for 7 years, it would output around 392,000 for 2025. And the R value for that model was like really high. The closer to 1, the better.
In addition to these models, we used a recursive linear regression model. It would take in the inputs of 2 years for all of the individual populations for the age groups, and then predict the individual populations for the age groups for the next year. We're able to use this output and feed it back into the model, allowing us to predict an arbitrary number of years. Based on this, we were able to predict or estimate the population growth for Bell County up to 15 years. Then using that estimation, we used it to estimate the population growth of Nolanville. Based on this, we estimate that the population for Nolanville will exceed 7,000 by 2025. Ultimately, our goal with this is to help predict future tax revenue, as well as understand future infrastructure needs, allowing Nolanville to understand what's within their means and what they need to do to prepare for the future.
The next element of our solution is the implementation of autonomous vehicle route planning. In addition to serving various parts of Nolanville, the routes will also tie into the proposed smart district.
We established that vulnerable populations in Nolanville do not have adequate transportation for basic daily needs. To meet this need, we worked on last mile route planning for the future implementation of autonomous vehicles or other public transit operations in priority neighborhoods.
Here's a Nolanville zoning map we created, which primarily served as a reference in our transportation planning to ensure service to priority populations and districts. Priority zones include the mobile home districts and downtown single-family district, in addition to retail and community hubs and highway access points. In addition to the stops labeled above, there is a planned route south of Highway 190 servicing a mobile home district. We have labeled the stops throughout the map using a circular icon to show how stops relate to various zoning districts.
The thermal map outlines the boundaries of Nolanville and shows the residential density of workers in Nolanville. As displayed, the northern center part of the city is the densest and becomes less dense as you follow out of the radius. We took these statistics into account when carefully choosing where the bus routes would stop. Additionally, of the roughly 1,750 working residents in Nolanville. 98% of them work outside of Nolanville, highlighting the importance of accessible transportation hubs. We also compiled some pie charts that show the age demographics and salary wages. The age chart shows a large elderly population, and the salary chart shows a majority of income over $3,000 a month.
This is an overview of the 3 proposed autonomous vehicle routes and future last mile transportation routes that we plan. As you can see, 2 of them are north of Highway 190, 1 is south, and they're indicated by the dashed lines of varying colors. The routes were designed around previously identified priority zones and tailored to our target populations and areas based on demographics, population density, and points of interest. The points of interest are indicated by red pins on the map and are places like provisional stores, churches, the post office, parks, and community centers that we thought would be important locations to service for the residents of Nolanville. Routes were also designed to service areas without direct access to the proposed route extension of the HOP, which is indicated by the solid red line on the map. So we want to provide a connection to that route as well. We've also established priority for the proposed routes based on various inputs and assumptions. And based on these inputs, we made the Plaza route the top priority because although the city center route has the potential to serve a greater amount of people, the Plaza route's distance from downtown makes it more of a priority for transit, followed by the city center route and then the Pecan Village route. Additionally, our routes tie in with the smart city development, as mentioned earlier. The planned city center route already ties in well with the proposed smart district route between avenues G and I, which would minimize the need for rerouting in the future when the smart district is implemented. However, if the opportunity arose, that route could be modified to serve the interior of the smart district.
Including an effective transportation plan will create many benefits for the city of Nolanville. Some benefits include a reduction in traffic, an increase in mobility, foregone trips, and the encouragement of healthier habits.
Our proposed solution addresses 3 areas of improvement for Nolanville: the economy, the environment, and connectivity. Through the 4 components of our solution, the smart district, route planning, population growth, and smart kiosk, we envision a Nolanville as healthier, safer, and more productive society with a more robust and self-sufficient local economy and a plan to meet the future needs of Nolanville citizens. Thank you for your time, and we'll now take any questions you might have for us.